Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 6.1, the Periodic Table, Part 2. Previously on Part 1, we learned that you are made out of stardust, that there are several macronutrients and about 5 elements that make up most of your body, and then there are macronutrients, and then there are trace elements. We learned that Mendeleev was doing the good work around the late 1800s. We talked about how the periodic table is organized into metals, nonmetals, and metalloids, and that properties are periodic, which means they repeat every so often. We learned about atomic radius, which is the distance from the center of an atom to its outer edge, and how it gets smaller as you go from left to right and gets bigger as you go down a column. Then we learned about electronegativity, which is the atom's ability to attract another atom's electrons, and how it goes up as you go from left to right, and it goes down as you go down a column. We also learned about ionization energy, which is the energy needed to remove an electron from an atom, and how that also goes up as you go from left to right, and goes down as you go down a column. And then we are going to talk about how this first periodic table was made. So Mendeleev got all of the elements, known elements at the time, and looked at their compounds, because a lot of those elements you didn't find in pure form, you found them in compounds, so he looked at them as oxides, and he realized that there was a pattern when you looked at their oxide formula. So you can see H2O, Li2O. So let's put that in a different format, and you can see all of the oxides are, 2 of them will bond with oxygen in this first row. It is a 1-to-1 ratio here, a 2-to-3 ratio here, a 1-to-2 ratio here, a 2-to-5, a 1-to-2, and then on these these are the hydride compounds, and then these are a little bit different. All right, so here is a first draft of a periodic table. It's pretty good. One of the ingenious things is that he left spaces. He was like, maybe we don't have all of the pieces, so I'm going to leave some spaces. And he was right. 6 years later, somebody discovered gallium. So the modern periodic table arranges elements in order of increasing atomic number, not atomic mass. But so Mendeleev did atomic mass. So please write this part down. So Mendeleev organized it by atomic mass because he didn't know about protons and atomic number, and this is a little bit better way to arrange it. And scientists have been adding elements to the periodic table as more are discovered. And the last naturally occurring element to be discovered is francium in 1939. The other ones have been synthesized. This is 70 years after Mendeleev said, there's going to be this element with these properties, and I'm going to call it ECA, or after cesium. And he predicted the properties for francium 70 years later. Good job, Mendeleev. Good job, periodic table. Here is this crowning jewel. And we have been talking about electron structure and electron configuration. So let's look at an example of boron. So electron structure was discovered after the periodic table was developed. And the question is the electron structure going to fit into the periodic table, or are we going to have to scrap the periodic table and start over now that we've figured out new things like electrons exist? Well, I bet you know the answer. It fits. So this tool is able to be used for things that weren't even known at the time when the tool was developed. And that means it's a really good tool. So let's look at electron configuration. This 1s2, we know that means that there are 2 electrons in that first s orbital, which is right here. And then this is the electron cloud. That's why it looks different than the way we normally draw electrons. And then this 2s2 means there are 2 electrons in the second s orbital. And this 2p1 means there's an electron zipping around somewhere in that first p, or, well, the first p orbital, but it is 2p. So there are 2 electrons in the first shell and 3 electrons in the second shell. And if we look at the electron configurations with their S, P, D, and F orbitals, which are crazy shapes, the main thing to take away is that it follows a pattern. So could we use this to predict the existence of new elements? So looking back 10 years ago, there was no element 117, and you could predict its properties given that it is a halogen. Is it still missing? No. Discoveries in science are made all the time. In 2010, element number 117 was discovered, and it was named Tennessean, I believe. Its atomic symbol is TS. In short, the periodic table is a very good tool, so you should learn to love it, learn how to use it, and I will talk to you later. This is the end of chapter 6.1. Good job.